Hi there, it's 1T, and in this video we're going to look at exponential growth models. In number one here it says Mandy's grandparents invest $10,000 for her at birth in an account that pays 8.5% interest compounded quarterly. How much will be in the account for her retirement at age 55? Well, that's awfully nice of her grandparents. So first of all, let's write the formula that we're going to need here. It's A, or the amount, is equal to P, the principal, or the starting amount, times 1 plus R over N, where R is the interest rate and N is the number of times the interest is applied to the account per year. If it's compounded quarterly, that means 4 times a year they're applying interest to the account. So N is equal to 4. You can see our interest rate written as a decimal would be 0.085. The starting amount or principal is 10,000. And notice she's just being born and it's going to be retirement at age 55. So there's your T. Time is normally in years, unless it's stated otherwise. So let's go ahead and plug in the numbers. So it's 10,000 times 1 plus R over N. Excuse me, I forgot to put to the NT power. All right. Um, Let me grab my calculator. I don't have it next to me here. Just give me a sec. I won't do this for all the problems, but I'll go ahead and put in this one. Actually, I forgot to plug in the numbers here. Let me do that. So 0.085 over 4 to the 4 times 55 power. Let's get our calculator out. We can put all this in one step. So it's 10,000 times 1 plus, I'm going to do alpha y equals for my fraction button, and it's going to be 0.085 over 4. And in parentheses, exponent button, 4 times 55, and let's go ahead and hit enter. And that's a lot of money. So 102.1069, and it'd be 49 on the cents, rounding to the nearest cent. So that would be $1,021,069.49. So they talk about the miracle of exponential growth. You can see that money grew into a lot over those 55 years. If you have a lot of time to let things grow, you can really see a much larger amount, some really good growth. All right. Number two is the same kind of problem, so you might want to try to do that one. All right, I'm going to go ahead and do it now. So we're using the same formula. I usually like to write the formula first. It helps students to avoid unnecessary mistakes. And then we'll plug in the numbers. This time our starting amount is $5,000. 1 plus R, notice it's 9.8, so your R is 0.098. Now this is compounded semi-annually. That means twice a year, every 6 months. So N is 2. So this will be a 2 here. And then it's going to be 2 times, in this case, it's 6 years. You're saving for a car here. And if you plug those numbers into your calculator, you should get $8,877.20. So that'll be a nice down payment. It's better than zero, that's for sure. Let's move on to number 3. So 12,000 is invested in a long-term trust fund in which the interest is compounded continuously. Find the amount in the account after 15 years. So anytime you have continuous interest, you're using what I call the PERT formula. Notice A equals P times e to the RT. By the way, you don't need to memorize these formulas. You'll be given the formulas, but you should know that if it's compound interest, that's when you're using the PERT formula. So notice this time our starting amount is 12,000. Our time is 15. And they're telling us for this first case, the interest rate is 4%. We'll use 0.04. So let's plug in the numbers. We have 12,000 times e to the 0.04 times 15. Let's go ahead and do that one. Excuse me. So 12,000. We'll do second ln. That's your e to the x button. And we'll put 0.04 times 15. It's 21,865 and let's see, 43 cents. All right, I would encourage you to go ahead and do the next one. The only thing that's going to change is this, instead of being 0.04, it'll be 0.08. So I'm going to go ahead and write that. So 12,000 times e to the 0.08 times 15. And hopefully you've already tried it. Put it in. You should get $39,841.40. So you can see that the interest rate being doubled caused the money to almost double. So interest rates are important. We're trying to make money. We want to find the highest interest rate we can. We just have to be careful that we don't risk too much, because usually if you get a really high interest rate like 12%, there's a risk. And so you have to be aware of that kind of thing. Let's move on to C. It says, how long will the account, or will it take the account to grow to a value of $100,000 if the interest rate is 4%? So basically we have this case here, but we don't know T. And so I'm going to go ahead and write our what we'd call the growth formula. We're still starting with 12,000. It's e to the RT. I guess I should put in 0.04 times t. Now we're missing one thing. Notice we want this value, we want this money to grow to 100,000. That's going to be our A. So it would be 100,000 equals 12,000 times e to the 0.04 times t. Now what you probably ought to do is think about how you would solve this equation. We've done something like this in the previous section, 4.4. All right, let's see what you did. See, the problem is I have an extra number here. Notice if I had base, exponent, answer, I could switch forms, and that would enable me to solve for t. But I've got this extra 12,000 here. So let's go ahead and divide both sides by 12,000. Now I could leave this, I could even leave it as 5 over 6 because this reduces. Oh wait, no, that's not true. Anyway, you could simplify this fraction and use that number. I'm just going to go ahead and use lots of decimal places. If you divide 100,000 by 12,000, You get 8 point, and then the 3 just keeps repeating. And so I'm going to use, I guess 3 threes should be enough. On the other side, we have e to the 0.04t. Now, we're in a position now where we can switch forms. We certainly can't use the equal bases method. I can't write 8.333 as e to some power. So I want to switch forms. This is a log base e of 8.333, and that's equal to 0.04t. Remember, in exponential form, in logarithmic form, the exponent is by itself. Notice if I check this using around the world, which is something I often do, e to this power equals that. That's what we have. So we just want to be careful that we change this correctly. Now, we don't write natural logs or base e logs using e. This will be natural log of 8.333 equals 0.04t, and the only thing left to do is divide by 0.04. The only thing I would encourage you to do is put this number, the 8.333, in parentheses. So let's go ahead and do that. Whoops, not wanting to show very well. So natural log of 8.333 divided by 0.04, and you get t is 53. So that's about 53 years. That's a long time. You don't want to have to wait 53 years for your money to get to 100,000, or at least you'd rather not. Now notice that in D, we're doing the same exact problem. The only difference is now our interest rate is 8%. It's doubled. So let's see how much time it'll take for our money to grow to 100,000. I'm just going to go ahead and put my answer up. Hopefully you've already tried this. If not, you can stop the video right now. So you should get 26.5 years. All right, let's move on to the next page. Excuse me. It says, how long to the nearest tenth of a year will it take an investment that's compounded continuously to double? First of all, if the interest rate is 3.5%, and then if the interest is 8.75%. Well, first of all, this interest is compounded continuously, so we're going to need the PERT formula, A equals P times e to the RT power. Notice how long will it take to double? Okay, so here's where we have to think a little bit. We really could use any number, but we're going to use 1 for P. That means if our money doubles, it's 2. Now the interest rate we said was let's see, R here is going to be 0.035. And we're solving for t. And so this is the equation we have to solve. 2 equals e to the 0.035 times t. So we're going to want to switch forms. Notice we have base, exponent, answer. So this is a base e log. It's the log of 2 is equal, log base e of 2 equals our exponent 0.035t. And so remember, we want to write this as the natural log of 2. That's 0.035 times t. We'll divide both sides by 0.035. And so if you divide that on your calculator, find that answer, you should get a 19.8. So you could say about 20 years or 19.8 years. Depends on how much they're wanting you to, or how accurate they want your answer. So about 20 years. All right, so I would encourage you to try the other one. Again, the only difference is going to be the interest rate. So we'll have 2 equals e to the 0.0875t, be the natural log of 2 equals 0.0875t. Now you can do like I did over here if it's helpful. I'm just taking a couple of shortcuts here, but it's the same process. We'll divide by 0.0875. By the way, I'm just getting over a cold here. I hope the recording sound is not too bad. And so I got 7.9. So you could say 7.9 years or about 8 years, depending on the level of accuracy that they want. All right. So you can see interest rates make a big difference. It's less than a half of the number of years. All right. I'm going to stop here and I'll do the rest of this video as a separate video, part 2. Where's my arrow? There we go.